Out in the vast darkness of space, some stars tear up the cosmic rulebook. We think we know how they work, but certain celestial objects are so strange, they challenge our basic understanding of physics itself. Get ready for a trip to the cosmic twilight zone. We're going to investigate a star that dims for no obvious reason, a zombie star that refuses to die, and theoretical objects made of matter that shouldn't exist. These cosmic oddballs are forcing us to rewrite what we thought we knew about the universe. The Enigma of Tabby's star. Our first stop is KIC 8462852, now famously known as Tabby's star. In 2015, scientists reviewing data from NASA's Kepler telescope found it was dimming in a way that made no sense. While a planet passing in front of a star might cause a 1% dip in brightness, this star's light was plummeting by a mind-boggling 22%. These dips were also chaotic, with no regular pattern. So, what in the universe could block that much light? The leading natural theory involves a massive orbiting swarm of comets or dust. However, a cloud that large should be heated by the star and glow in the infrared, and early observations saw no such glow, leaving a huge hole in the explanation. The lack of a simple answer opened the door to a much wilder idea, an alien megastructure. The theory proposed that the dimming could be a gigantic collection of orbiting solar panels, a Dyson swarm, built by an advanced civilization to harvest the star's energy. This was so compelling that the CD Institute pointed its powerful radio telescopes at the star, listening for any hint of an artificial signal. They found only complete silence. Today, Tabby's star remains a profound cosmic puzzle. No single theory perfectly explains everything we see, reminding us that the universe is always ready to throw us a curveball. The zombie star that refused to die. When a really massive star runs out of fuel, it dies in a single gigantic explosion called a supernova. It's a one-and-done event. But what if a star could die, and then die again? Meet IPTF-14HLS, the zombie star. Discovered in 2014, astronomers initially thought it was a normal supernova, but instead of fading away, it just kept going. For over 1,000 days, it stayed bright, dimming and re-brightening at least 5 times. It was like watching a star explode over and over. When astronomers checked archival data, the story got even stranger. They found evidence of another explosion at the exact same location back in 1954. This star had apparently blown up, survived, and did it again 60 years later. One leading theory is a pulsational pair instability supernova. This is thought to happen in the universe's most massive stars, which become so hot they trigger violent eruptions that blow off their outer layers, but leave the core intact. This could happen repeatedly over decades. The catch is, this kind of explosion was thought to only happen in the very early universe. Finding one today, as one scientist said, would be like finding a dinosaur still alive. Beyond the neutron star, the realm of quark matter. When a massive star dies, its core collapses into a neutron star, an object so dense a single teaspoon of it would weigh as much as Mount Everest. For a long time, we thought this was the densest matter could get before collapsing into a black hole. But what if you could crush matter even further? What if you could break down the neutrons themselves into a soupy sea of their fundamental building blocks, called quarks? This new state is called quark matter, and a star made of it would be a quark star. These theoretical objects would be even smaller and denser than neutron stars, the absolute last stop before a black hole. For decades, quark stars were just an idea, but now, we're finding tantalizing hints that they might be real. One clue came from a gravitational wave event detected in 2019. After a cosmic collision, the leftover object had too much mass to be a stable neutron star, yet it didn't seem to collapse into a black hole, a profile that could fit a quark star. Another compelling candidate is an object called HES-J 1731-347. It appears to have a very low mass for such a star, yet it also has an incredibly small radius. This strange combination is tough to explain with standard models. but it's a perfect fit for some theoretical models of Quark stars. From the baffling dimming of Tabby's star to the impossible rebirth of the zombie supernova, and into the theoretical realm of quark matter, the universe keeps showing us that it's far stranger and more wonderful than we ever expected. These cosmic anomalies aren't just curiosities. They are signposts pointing us toward new physics. They challenge us, inspire us, and remind us that we are just beginning to scratch the surface of the great cosmic mystery, as the laws of physics are actively being rewritten by the stars themselves. Now we're going to get even weirder, exploring stars made of stuff that sounds like it was pulled straight from science fiction. If your mind is blown and you want to keep exploring the cosmos with us, make sure to hit like, subscribe, and ring the notification bell.